Independent factorial ANOVA. We'll start with the basic analysis and how to set up an independent factorial ANOVA. For our independent factorial ANOVA analysis, we are going to look at whether drinking coffee and using the internet has an impact on reported sleep quality. So since coffee drinking is measured as a categorical variable, so either people drink coffee or they don't, as you can see here, and internet use has been classified into categories where we have low, medium, and high users, we are going to conduct an independent factorial ANOVA because we have categorical independent variables and then an interval ratio dependent variable. So we can see here that since we have 2 levels of coffee and 3 levels of internet use, this would be a 2 by 3 independent factorial ANOVA, and sleep quality here seems to be measured on a 1 to 10 scale. So to conduct this analysis, we're going to click on Analyze, General Linear Model, Univariate, and we'll just reset everything here. So the only 2 boxes we need to worry about here in this window are the dependent variable and the fixed factors. So the dependent variable, we're just going to put sleep quality right there, and then the fixed factors actually just means independent variables. So we can select coffee and internet use, put them there. In terms of setting up the preliminary analyses, and this is just to see whether or not we have significant main effects or a significant interaction or both, the only things we need to worry about are the plots and the options boxes here. So for plots, this is how we can ask SPSS to generate a plot of the means so that we can visually inspect the relationship between the different groups. So in this case, you have to select which variable is going to go on the horizontal axis and which one will be separate lines. And if you recall, the vertical axis is actually going to be people's scores on the dependent variable. My personal preference is to put the variable with more levels on the horizontal axis. So in this case, since internet use has 3 levels, I'd put that here. And coffee has 2, so I'd put that on separate lines. And then once these are here, you click Add. And once you have something that appears in this box below, you can click Continue. Beyond that, we just need to go to Options. And we're going to ask for the descriptive statistics, the estimate of the effect size, and then our homogeneity of variance test. So once we've selected all of these, we can proceed. So the results are pretty straightforward at this point. Up here we just have a list of the factors that we're examining as well as the groups within those factors. So we can see here at coffee we have 1s and 2s, so yes and no, and 9 people per group. Internet use we have 1, 2, and 3, and these mean low, medium, and high, and we have 6 people per group. So looking at the descriptive statistics, we can see here that for the yes coffee drinking group, we have these means, and the no group, we have these means here, and then this is collapsed across the yes and no's, and then the total, so the grand mean would be right there. Next we have Levine's test for quality of error variances. So for independent factorial ANOVAs, if we do have a significant Levine's test, so that means that we have a problem with our variances, we aren't going to make Welch's correction like we did with just the independent ANOVA. What we're going to do instead is just make an adjustment to the post hocs if necessary. So that would mean using Games-Howell over Sheffay's in the event that this is significant. In this current example, it's not 0.909, it's much larger than 0.05, but if it were smaller than 0.05, we wouldn't be making the correction down here. We'd still just interpret this table. Okay, next we have our ANOVA table, and we'll come back to that in just 1 second. First, we'll look here at the plot that we asked SPSS to generate. So we can see here that for those who drink coffee, their means are up here relative to those who don't drink do drink coffee. And this is their reported score in terms of sleep quality, and then these are the low, medium, and high groups. So we can see that for both groups, so coffee drinkers and non-coffee drinkers, the low internet users seem to report the most or the highest quality of sleep, and then it kind of declines for both groups. So whether this is significant or not, that's what we need to check our analyses for. So going back up to our table, since we're running a factorial ANOVA, SPSS does generate a lot of extra rows in the data set, but the only one that we really need to worry about is, there's a few of them, but this one here, coffee, internet use, coffee and internet use, and then the error. And that actually gives us everything we need to interpret our results, our degrees of freedom for the first part of it and the error term. And then if you were to calculate your effect size by hand, where you take the sum of squares model divided by sum of squares total, it's actually the corrected total you're going to use and not the total. But when you're using SPSS, you don't really need to worry about that. So what we can see here is that coffee had an F of 72.9 and it was significant. So for 1 and 12 degrees of freedom, 72.9 was much larger than the critical value there. So we can conclude that we had a significant effect for coffee drinking. If we look at internet use only, we see again that a score of 54.7 was much larger than the critical value for 2 and 12 degrees of freedom. So again, our results are significant. However, if we look at the interaction between coffee and internet use, we see that value of 6.5 for 2 and again 12 degrees of freedom is again larger than the critical value in that we have a significant interaction. So you can see down here what the overall effect size is for this model. So it's taking into consideration the effect for coffee, internet use, and the interaction and adding them all together. And so overall, these two independent variables as well as the interaction explain explain about 95% of the variance in reported sleep. So either way, whether this had been significant or not, we still have more steps to do. So we'll look at both scenarios. So we'll pretend in the first scenario that coffee and the interaction here was not significant, and we'll look at what we need to do, and then we'll look at what we need to do when the interaction is significant. Next, we'll look at how to proceed if we have a non-significant interaction. Okay, so we just ran our preliminary analyses, and yes, in the current example, we had a significant interaction, which would mean that in reality, we shouldn't be looking at our main effects, and we should start examining simple effects. However, we'll first start with an example where we pretend that that interaction wasn't significant, and we need to conduct certain follow-up analyses. So, if we didn't have the interaction between coffee drinking and internet use, what we need to examine is just the independent impact of coffee drinking on sleep quality and the independent impact of internet use on sleep quality. And these are called main effect analyses. So we know from the analysis we just conducted that both of the main effects were significant. So coffee on its own impacts sleep quality, and internet use on its own impacts sleep quality. So since coffee only has 2 levels, we know with the significant F ratio that means that there's a difference in the reported mean for the coffee drinkers compared to the non-coffee drinkers. And if we look at if we were to look at the actual means, we'd be able to see which group is higher or lower on the independent variable, the dependent variable. However, with internet use, we have more than 2 levels, so it's impossible to know where the differences lie without conducting some post hoc analyses. So to do this, we're going to go back to the same options window. So we're going to go General Linear Model Univariate. We'll click here, and this time we need to now add our post hoc analyses for internet use. So we click here. Coffee, if you try to run post hocs on it, it's going to tell you that you only have 2 levels and you don't need to. But internet use, we have 3, so we'll select that here. And since we had equal variances, we're going to select the Cheffe test. And we'll go from there. So we click continue, and then everything else we can actually just leave it as it is. Okay, so what we would report is that, again, we're pretending here that this is not significant, so this is bigger than 0.05. So in the event that you were to obtain results like this, we would say that coffee had a significant effect on sleep quality, so F was equal to 72.9, and internet use also had a significant impact on sleep quality, and F was equal to 54.7. So if we look up here, if we look at just the coffee drinkers, we see that the average for the yes drinkers was 4.5 and the no's was 7.56. So what we conclude by looking at these two tables is that those who drank coffee reported lower sleep quality than those who did not. However, for the internet quality, we do need to look at the low, medium, and high groups and actually look at the post hoc to see whether the low group was reporting significantly better sleep quality than the medium group and significantly better sleep quality than the high group, because we can see there that we have a mean of 8.3, 3 for the low group, 6 for the medium group, and 3.83 for the high group. So if we go down here, we have our post hoc test using Cepheid, and we can see that if we compare low with medium and low with high, that we have significant results, and then medium with low, medium with high, significant results, etc. And then we can just skip this last table here, and then these are the same plots. So what this is telling us is that there are significant differences here between each of the groups, and then the other test, or our original F test, tells us that the differences were significant as well. Finally, we'll look at what to do when we have a significant interaction. So we just covered how to interpret the main effects in the event that we had a non-significant interaction. Now we'll talk about what to do if we do have a significant interaction. So as you may recall, if the interaction is significant, we are no longer really interested in the main effects. So what this means is that if there is an interaction between coffee and internet use, we are no longer concerned with the single impact of coffee on sleep quality and the single impact of internet use on sleep quality. We're interested in how these two variables together influence sleep quality. So to do this, we're going to have to ask SPSS to do a simple effects analysis. And what a simple effects analysis does is it's going to look at the difference between internet use for the coffee drinkers and how that influences sleep quality, and then the difference in the non-drinkers and depending on internet use, how it influences sleep quality. And then it'll actually do the opposite of that. So it'll look at the people who use low internet and the yes or no coffee drinkers and how it influences sleep quality. And then we'll look at just the medium group and look at the difference between coffee consumption and sleep quality, etc. So in Factorial ANOVA, if you have a 2x3 design like we do in this case, you're going to have 2 plus 3 simple effects to look at. So we'll have 2 plus 3, 5 in total. Unfortunately, SPSS does not have a function through the dialog boxes to generate the simple effects, so we actually have to do it through syntax. And the easiest way to do this is to go back through the dialog box, go back to our analysis, and instead of clicking OK, we're going to click Paste to generate the syntax. But first, let's just make sure we don't have anything we don't need. So we don't, let's uncheck the homogeneity of variance test. We can keep the descriptives and this here. Post hocs, we will remove them because since we're no longer looking at the main effects, we don't want the post hocs for the main effects. And we can leave everything else if we'd like. So we'll click Paste. And what this does is it opens a syntax window. And we can see here that we're doing an ANOVA where we have sleep quality by these two independent variables here. We can see here that our plot is going to be the interaction of the two, so internet use by coffee. We've asked it to generate our effect size and our descriptive statistics. And we also are using criteria of 0.05 for the alpha. And then our design here, it just kind of repeats basically what's on this first line. It says that we have coffee, internet use, and the interaction of the two. So to add the simple analysis, we just have to add 2 lines of code to the syntax. So we'll add them right here under the plot. So we need to type in means, so estimated means equals tables, open bracket. We put the interaction, so internet use times coffee. And then we say compare, and we list in brackets one of our 2 independent variables. So we'll put internet use. And then the next one B means, so same thing again, tables, internet use by coffee again, sorry, no spaces, compare, and this time instead of internet use, we will just put coffee. So now we can run this. So we'll highlight it, click run. Okay, so we have our output here, and we can see that for the most part it looks the same. So we can see here the groups, the descriptive statistics for the groups, and that main ANOVA table from our preliminary analyses. And if you recall, the only reason we were doing these simple effect analysis, or a series of simple effect analyses, was because this value here was significant, meaning that we had a significant interaction between coffee drinking and internet use. So if we continue to scroll down, we asked SPSS through the syntax to generate 2 additional sets of results. So they fall under the estimated marginal means, and if you look here, we have one set here, and then a second set, and then we actually have our plot at the end. So there's a lot of tables. These are the descriptive statistics for each group by the groups we're comparing. These are similar to the post hoc comparisons, and then these are actually the F-test that we want to look at. So what we can see here is that for the yes coffee drinkers, okay, if we compare those who drink coffee only, if we look at only them, and we compare the low internet users, the high internet users, and the moderate internet users, we can see that there is a significant difference somewhere in their sleep quality. And we can see that because this value here is significant. So this means for only people who drink coffee, there is a difference in reported means somewhere depending on internet use. Now if we look at the non-coffee drinkers, we can see the same thing here. So we have the F right here, and we can see that it's not significant. So this means that for the non-coffee drinkers as well, we have a significant difference somewhere. So if you recall, since our internet use has more than 2 levels, we actually need to look at the post hocs to see where the differences fall. And just the way the tables come out, that table is actually just above us here. So if we look at the yes coffee drinkers, we can see that there's a significant difference between the low internet users and the medium users, and the low internet users and the high. And we can see that because this is significant. And just for information, these comparisons are interpreted in the exact same way that the Games Howl or Sheffe would have been interpreted with just the simple ANOVA. However, in this case, since it's being done as part of these simple analyses, it's using the least squared difference test, but essentially it's the same way. And then if we look at, again, for the coffee drinkers only, the medium and low group still significant, and medium and high slightly less significant, but still smaller than 0.05, so we can conclude that they're different. And then this here is just the remaining relationships from the opposite direction. So what we can conclude for the yeses is that there is a difference between all 3 groups. And then if we look at the no group, we can see here that low and medium don't report any differences. However, low and high do. If we look at medium, we see again no difference with low, but then that same difference with high, and then high is different from both. So that's how you would interpret the post hocs of these 2 simple effect analyses. So if we go down, we actually get now the opposite relationships. So again, we have the descriptive statistics, the comparisons, and then now we actually have the 3 other simple effect analyses we're missing. So this time it's looking at, for the low internet users, the difference between the coffee drinkers and the non-coffee drinkers, and then the medium internet users, the difference between the non-drinkers and the drinkers, and then the same thing for the high. And what we can see here is that there is no difference for the low, whereas there is a difference for the medium and high. In this case, since we only have 2 groups that we're looking at, we don't actually have to look at this table to see. However, the table does reflect the same things. We can see that the yes and no's are not significant for the low group, but that they are for the medium and the high groups right here. Okay, so looking at the profile plot here, we can interpret the results of our main effects. So we looked at whether there was a difference between any of the internet use for the no coffee drinkers and the yes coffee drinkers. Then we looked only at the low coffee drinkers to see if there was a difference here between those who drink coffee and don't. And then we looked here at those who drink coffee and don't, and finally here. So of our 5 simple effect analyses, 4 of them were significant and 1 of them was not. And then when we looked at the post hocs of the simple effect analyses, we were also able to see where there were differences and where there were not. So starting with the non-coffee drinkers and whether or not there were any differences based on internet usage in reported sleep quality, we saw that there was a difference somewhere. However, there was no difference between the low and the medium users. However, there was a difference between low and medium with high, where as we can see here that the low and medium users generally reported high quality sleep and the high users reported less quality sleep. In the next simple effect analysis, we looked just at the yes coffee drinkers. And what we saw in that one with the post hoc analyses was that there was a difference between the low group and the medium group, as well as the medium group and the high group, and then finally the low and high group. And what we can see looking at the means here is that the low, for those who drank coffee, those who didn't use a lot of internet still reported good sleep quality. However, the moderate and high users definitely dropped off here and reported less sleep quality. So they reported less than them, and then they reported even less than them. In our next series of simple effects, we looked at these relationships here. The first one looking at the differences for just the low internet users between the coffee drinkers and non-coffee drinkers was not significant. So if you recall, just up here, this one was not significant, and we can see here that's not surprising. These look pretty similar. When we looked at this one, the results were significant. So we did have a difference between our we did have a difference between our coffee drinkers for those who were medium internet users, and we can see here that the no group was significantly higher in terms of sleep quality than the yes group. And again, since this was only looking at 2 groups, we didn't need to look at the table, but the table did reflect the same things. So these were significantly different from each other, and then we saw a similar trend right here when we looked at only the high group. So that last simple effect showed us that the non-coffee drinkers reported more or better sleep quality than the coffee drinkers. So that's how you would interpret the 5 simple effects, and those are the ones that you would want to report once you would indicate that you had had a significant interaction. Since we do have that interaction and we do have different things going on depending on the level of the independent variables that we're looking at, we are no longer interested in the overall effect of coffee drinking and the overall effect of internet use, but instead the combination of both effects. And that should give you everything you need to report your independent factorial ANOVA results.